Good morning. Shall we start? This was the system yesterday we had went through for 2-3 minutes. You see this, then we shall go for new topic. So we had indicators, sensors. These all field devices are digital. Push buttons. Then input terminals or PLC. And here only you see you have power supply here itself. This is the power terminal. Here line neutral earth. I have connected line neutral earth is below. This is the communication port of this PLC. Output terminals. We have AC drive and motor is connected here. It is connected. Motor is connected here. And AC drive, VFD, variable frequency drive, motor. Uh, Today you see, yesterday motor direction was not visible. So this video is available. You can see here. The direction of motor will change. Now it has been running in forward direction. It will change the direction. You see, direction is changed. And the direction is being changed by AC drive. Again, the process repeats. As we press stop push button, as per our logic, system will stop. When we press it does not start, then we check the indicator. We get I0, X0 indicator, we get high. Then we fix this proximity metal detector. Then it runs. Okay, done. So today our task could be to extend this project with some more features. So we shall have implementation of HMI in first session, and in second session we shall go for SCADA. I hope my audio is clear because today I am not using earphone. If you have problem in audio, then you tell me I shall use earphone. Okay, so what should we do now? We should start discussion about HMI. Okay, let us go through this. So yet we have understood that using PLC, we can make one machine automatic. We have understood how do we wire field devices to PLC. In industry also, we have to wire it the same way. The number of inputs, outputs will be more there. Audio is very low, so I shall use earphone. Fine, I hope. So, field devices we have connected yesterday. I told you four points you have to remember while wiring inputs outputs to PLC. Sync type, source type, you have to remember. When it is sync type wiring, you have to connect all your field devices in between positive path of SMPS. When it is source type, you have to connect field devices in between negative path of SMPS. Fine. With PLC, your machine will be automatic, no doubt. You have seen yesterday, you people made program, I downloaded here, and it was working as per the sequence, as per the logic we have made. But with PLC only, the system will not be that flexible. The system will not be that flexible. That system will not be that user friendly. So there are two major requirements for a good machine. And these two requirements are monitoring of data and controlling of data. I shall explain this. Monitoring of data, controlling of data. So you should understand it in interview when you go to have discussion about HMI and SCADA. You will have to explain all these things. Why do we use HMI? What is the use of HMI? Why do we use SCADA? All these things you need to explain there. So we can say that HMI, since we are talking about HMI now, We can say we have two requirements. First is monitoring of data, second is controlling of data. Data means the addresses we have used in PLC program, like input address, output address, timer, preset value, timer, accumulator, counter, preset value, counter, accumulator, temperature, pressure, flow, level, displacement, all these things we need to monitor. If we are not monitor, if we are not able to monitor, we won't understand what's going on. For example, if we have a motor and that has to run for 1 hour, we go to the machine and we want to know how long it has finished. If we don't have monitoring system, how shall we come to know how many minutes or how many seconds the motor has already run and how long will it run more? So we will not be able to monitor that. Production is going on, we go and we want to know how many jobs have been ready yet, how many products have been ready. We won't be able to know if we don't have any monitoring system. We go to the machine and we want to know the temperature of furnace, we want to know the temperature of boiler, we want to know the level in the tank, we want to know uh, any information. We want to know which input is on, which output is on, which sensor is on, which is not on. If we have to know all these things by seeing PLC only, we cannot uh, understand. By seeing PLC only, we can't say what is the temperature. We can't say how long the timer has finished. We cannot monitor accumulator. So these things, the data status, we need to monitor while running system. So this is a big requirement. There is one option we can monitor. Yesterday you had seen I had connected PLC to laptop, received existing program, went to monitor mode, and in monitor mode we were able to monitor the status of data, addresses. You had seen I pressed start button and it was blue color yesterday in code in GX developer. You had seen that we found the problem of sensor in monitor mode. So we were able to monitor. We saw yesterday that timer was running. All these things we can monitor when we have software. We can receive existing program. We can go to monitor mode. We will be able to monitor. But practically, it is not possible to use PLC software to monitor the running status. Why? First, First of all, one operator has to operate the machine. Operator does not know how to receive the program, how to communicate, how to go to monitor mode. We cannot connect our laptop or PLC all the time to PLC. We cannot connect our laptop to PLC every time. An operator cannot do all these things. First practical problem. Second, we who has joined the group? Okay, okay, let it be. Another practical problem you see, another practical problem is we have made program where we have 35 steps. When you go for big program, when you go for big machine, the steps would be 5,000, 6,000, 8,000. So when you have, suppose 1,000 only, when you have 1,000 steps, you have many ladders. and you have to monitor the status. I think it's not possible to monitor the status because as you scroll up, scroll down, many status will get changed and you won't be able to see that. So practically, it is not possible to use PLC software always to monitor the running status of machine, or you can say the running status of data. So monitoring of data is not possible by PLC software practically. We can monitor, but that we used that monitoring we use for troubleshooting and all. But we don't use PLC software monitor mode to monitor the running status every time. Second requirement. Second requirement is controlling of data. In simple, I shall tell you. Second requirement is we need to change some numerical value on data location. We need to change numerical value on some data location. Which data? You can say in simple preset value. We want to change preset value as per our requirement. For example, one machine has been producing three types of product. For product one, motor should run for 15 minutes every time. For product two, the same motor, the same timer in the same program, it should run for half an hour. If you change the product for third product, suppose the same timer, the same program, the same motor, it should run for 10 minutes. So you can see, as per your requirement, you have to change the preset value of timer. If you have packaging machine, for product one, in one box, you have to pack 6 jobs. So preset of counter will be 6. For another product in the same box, you have to fill, suppose, 12 jobs, 12 products. So preset you need to change again. So like that, you need to change the preset value as per your requirement. Again, you have one option that PLC software you can use. You can receive the existing program, can change preset value and rewrite the program or do online edit. Again, one programmer will be required and operator cannot do all these things. In fact, you will have to wait, you will have to stop the production and you will have to do all these edit. So the thing is, we have not to disturb production, and in run mode only we have to change some numerical value without changing program. Be very clear, without changing program, we have to we have to make some modification on some data location, like preset value location. So two requirements: monitoring of data, controlling of data. These two are very important part of a good system. And I hope you understand that if we don't have monitoring system, we would be wondering what's going on in our machine. If we don't have option to control the data, means changing the data, we will have to stop our machine many times. We will have to modify our program. So monitoring and controlling, these two are very important. For that, we have two systems. One is HMI, Human Machine Interface, or we call it man-machine interface also. Initially, it was called man-machine interface. Now it is HMI, Human Machine Interface. So human-machine interface, and another system we use is SCADA, Supervisory Control and Data Acquisition. About that, we shall have discussion after lunch. First, let us see HMI, Human Machine Interface. See here. Human machine interface, this one you see, you can have two types of screen. You will have two types of screen: control panel, operator panel and touch panel. If you have operator panel, on operator panel you can see you will have some function keys, means hardware key. So some people have seen HMI in industry or in some videos. It will have some hardware key that we press and we operate. It will have some numerical key also so that we can change the numerical value. We'll have one screen. So this we generally call operator panel, and touch panel you can see will have just one screen. Touch panel will have just one screen. It won't have any hardware key on it. It won't have any hardware key on this. So these keys for touch panel, you will have to create keys in software. So for HMI, you have to use software also. For HMI, you have to use software also. Okay. Now, these are the front, uh, these are front face of this HMI. Now, behind HMI, what do we have? On front, you have seen we have screen, we have keys, and here we have just one screen. You have gone to ATM, right? In ATM, sometimes you operate through key, and in some ATM, you just operate all the things from uh, screen only. So we have operator and operator panel and touch panel there itself. Now behind any HMI, what do we have? Behind any HMI, we have first of all power terminal. You can see power terminal, positive, negative, earth. Positive, negative, it will always be DC power supply and always 24-volt DC. But I have seen some old HMI where it's small HMI, not big one, small HMI, it had 5-volt DC also. But generally, HMI power supply will be 24-volt DC. 24-volt DC. Done? Okay. Next, another thing, what do you have on HMI? I shall show you. I have HMI. I shall show you. We will work on that. Real-time HMI we shall use here. We will have some communication ports. We shall have some communication ports behind HMI. One port we use to communicate our HMI with PLC. So you can say it is interfacing port. We interface HMI to PLC through interfacing port. So one port you can use for interface. I shall tell you many things about HMI today. Don't be worried. Keep patience. Another thing is one port will be used to send or receive HMI design, you can say, or program, let us call it. HMI program, you call it. So HMI program, although it is like visualization design, so that design you have to send or receive, if you have to do from HMI, one port will be used. Now, we have option to configure these communication port. We can change the feature of communication port. We have option in software. So you can go to the software and you can assign, okay, this port I shall use for PLC, this port I shall use for program send receive. So that can be changed also. Another thing, how many HMI, how many PLCs we can interface with one HMI? Generally, when you visit industry, you will find with one PLC, one HMI is used. So one PLC, one HMI. But if you have two communication ports on your HMI, then two PLCs can be interfaced at the same time. If you have three communication ports on HMI, then three PLCs can be interfaced at the same time. And I have used, not in industry, but when I was learning HMI, when I was doing some experiment on this, I had connected Mitsubishi and Allen Bradley, two ports I had. So one port I used Mitsubishi, through another I used Allen Bradley, and both PLC data we were able to monitor and control. So if you have three ports, you can interface three PLCs. Be very clear. So these are few information. So they will ask you about HMI. You will explain all these things, monitoring, controlling. So if sometimes they can ask you, okay, what is the use of HMI? What is the use of HMI? You can say, as I have written on screen also, you can see I have shown you here 4 points I have mentioned. 2 points you have already understood. First is monitoring of data, you understand. Second, controlling of data, that you understand. Third is data scaling. This is a good feature on HMI, in HMI software. Data scaling. What is this? I shall tell you. Keep patience. Data scaling. And do you know all these four features will be applicable for SCADA also? So understand it. You can answer these 4 points in for SCADA also. So data scaling. What is this? I shall tell you. One guy had asked, why did we divide percentage MW1 by 1000 in Codesys visualization? You remember, no? That timer meter display or digital display, we had taken percentage MW1 divide by 1000. An answer had also come. I don't remember the name of the guy, but he had answered that also. That was correct. But everyone, I think, did not understand and they did not think about this also. See, there we did data scaling actually. We did data scaling. How? Who had answered this? I think Suresh, or I don't remember. Are you present? Can someone tell me why did we divide by 1000?
Because this data scaling means the what we have done in our PLC in HMI, we can see the same tanks and same control valves and everything how it is operating.
That is okay. But can you tell me why did we divide that percentage MW1 by 1000
Yeah,
in Codesys visualization?
because I think our input was in seconds, and PLC has PLC gave the output in milliseconds.
Yes, yes. What is your name?
Jose, I am the one who asked question on that day.
Okay, 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 okay. You are correct. And you had answered also, right? Yeah.
No, now only I am answering, and that day
Okay,
someone
no.
else was answering.
Oh,
Then I
someone
could
else
understand.
answered. Okay, okay, fine. So see, everyone, why did we divide that by 1000? Because you did not notice. Okay, you can notice after session, you can go to Codesys and you can open the same program and you can see in ladder actually. You run your program in ladder. You will see your timer accumulator will show you 1000 for 1 second, because one second has 1000 millisecond, right? 1000 millisecond is equal to 1 second. So that ladder or PLC, you can see say, is showing you time in millisecond. So for 5 seconds it was showing 5000, for 10 seconds 10,000. So in ladder you can see further, it will show you for 1 second 1000, 2 second 2000, 3000, 4000, 5000, like that. And in visualization we have divided that by 1000. If we don't divide in visualization also, it will show 1000, 2000, 3000, 4000, 5000, like that. So we divided that by 1000. That is data scaling. The same thing we have in HMI also. Like today we are going to use Mitsubishi PLC, correct? Can you tell me, in Mitsubishi, for 5 seconds, what do we take? Preset value. In Mitsubishi timer, for 5 seconds, what is the preset value?
50.
50. Yes, it is 50. 50. But in HMI, obviously, would you like to show 50 in HMI? No, you would like to show 5 only, no, for 5 seconds. But in PLC, you have 50 for 5 seconds. So in HMI, you have option, you can scale it. Or else another option is in your PLC program itself, you divide that by 10. For that, you will have to increase your ladder, you will have to go through arithmetic operation. No need to do that. You just go to HMI or SCADA where you want to display, there you scale it. You have option. Okay. Not only timer, but sometimes temperature, pressure, you can say analog signal. Tomorrow I will show you. Analog signal also we need to scale, because it's not like for 10, for 100 degrees Celsius, that device will show you 100 only. Another value can come. So let any value come, let any value come, we can scale that as per our requirement in HMI or SCADA. No need to do arithmetic operation in PLC software. Okay, done. So scaling of data is clear. Next is saving number of PLC input terminal. This is important, and believe me, you won't find this point anywhere in any document, because this is practical point. Practically we have seen and we have understood, okay, this is also a good feature and it is being used in industry also. For that you will have to concentrate. So concentrate please, I shall explain it, because if you are learning the things, learn it perfect. Okay, so I shall open Paint first. It would be better to explain there. So saving the number of PLC input terminal. It's not protection I am talking about. It's not protection. You can see number of input terminal we can save. Not input terminal I'm talking. We are not saving the input terminals. Protection I'm not talking about. I'm talking about we can reduce the number of PLC input terminal if we have HMI. Now, for example, you see. Suppose on your PLC, see, this is very practical thing. If you explain this, people would be happy in industry. In interview, if you answer this. See, on this PLC, suppose we have X0, X1, X2, X3, like that. We have some terminal export. Suppose 5 input terminals we have. Consider. Now, in this project, you have 1, 2, 3, 4, 5 input terminals, but you have 7 inputs in your project. See here, try to understand. You have to use 7 inputs in your project, but on your PLC you have only 5 input terminals. Clear? We have option. 5 inputs we can connect here, and for 2 inputs we will have to purchase one extension unit. But do you know, if you go to purchase one extension unit of Mitsubishi or Siemens or any brand, if you go for a good brand, its extension unit cost will start from 10 to 15,000. Will start actually. We don't know the maximum. So for 2 terminals, you will have to invest 10 to 20,000, you can say. So it would be costly. Your project cost will increase. So try to understand, you have 5 input terminals on your main PLC, on your PLC main unit. But you have to connect 7 inputs. In your project, you have 7 inputs. Now, obviously, you will have start push button. You will have stop push button. That is by sure. In any project, we have start push button, stop push button. And suppose after that we have 1, 2, and 1, 2, 3, 4, 5, 6, 7, 5. Suppose 5 sensors we have. Consider. So 2 push buttons and 5 sensors you have. Try to understand. 2 push buttons, 5 sensors we have. See, we cannot do anything. If we have sensor, we will have to connect to terminal. There is no other option. Sensor is automatic input. It is not operated by man. So this must be connected to PLC terminal. But if you have manual switches means the switches operated by a man, operator, like push button, selector switch, rotary switch. These are manual switches. If we have HMI, manual switches we can ignore. Listen, if we have HMI in our project, manual switches we can replace. How you see? So these two push buttons you are not going to use. Be very clear. Because if you have to use these two and five sensors, you will have to purchase one extension unit. And you have one HMI also in your project. So better what you do not connect these two push buttons, but you connect all sensors to your main unit. You have five sensors, connect all five sensors. But you will say, how shall we do start and stop? You are correct. How shall we do start stop? Let me show you. We have not connected start stop push button, but we can do start stop. How can we do? In our program, obviously, start stop circuit we will have like this, ladder we will have like this. Start stop ladder with this M0, latch X0 and X1, correct? X0 and X1. But now X0 has no push button, X1 has no push button. We have sensors here. So we cannot use X0 or X1 to start and stop. Be very clear. These two addresses now we cannot use, but we have to start stop. What we can do is we can use any flag what you have not used in your program. Okay, no? Any flag that you have not used in your program, that flag you use. Suppose I take here M50. I take here M50. And M50, M51 we have not used in our other ladders. Now, if M50 is on by any mean, this will get high and this will make a latch, other things will run. So it will start. If by any mean you operate M51, this will break the latch and your program will stop, your machine will stop. But how to get this M50 and M51 on? That is the question. Do one thing. Go to the HMI. In HMI, you create one key as you have done in visualization in the same way. Create two keys. And in its tap variable, you give M50. Its tap variable will have M51. Okay. Now in HMI, you can press this key, M50 will get high, your machine will start. In HMI, you press M51, M50 is high, it will stop your machine. Tell me, did you understand the points? Tell me, did you understand? Or if you have any doubt, you tell me, I shall clarify. I shall tell about that. Repeat it, what is that? 10:38, okay, just now. I shall repeat it. Okay, there are many things here. I shall repeat it, no issue. Anyone, did you understand or no one understood? Did someone understand it?
Understood, sir.
Understood, no? But I shall repeat, people who have not understood. Okay. I shall, Devankar, okay, I shall repeat it. See, first of all, what you have to understand, mute please. First of all, what you have to understand. First, you need to understand the requirement. You are doing one project. Listen carefully. You are going to do one project. See, all these things we do not have discussion in online session. But I have been seeing many people are interested to learn. So I have been discussing it. So listen carefully. This was not in my syllabus. I had not to discuss, but I have been discussing. So what was that? Okay. So you are going to do one project. In your project, you have 7 inputs. Be very clear. In your project, you have 7 inputs. 2 push buttons, 5 sensors. In your project, you have 2 push buttons, 5 sensors. And you found one PLC. Suppose in your college, you had one PLC, small PLC. But there is a problem. The problem is on that PLC, we have only 5 input terminals. We have to use 7 inputs in our project, but we have only 5 input terminals on that PLC. And in our project, we have HMI also. So for 5 inputs, okay, 5 inputs we can connect to PLC, but what about 2 more inputs? Because we have 7 inputs. You will have to purchase one extension unit. Extension unit again will cost 10 to 20,000 as per brand. It depends on brand. So your cost will increase. For 2 inputs only, your cost will increase. So do what you do actually. Manual switches you ignore. Do not use manual switch in your project. Like push buttons are manual switches. So start stop push button you do not connect to PLC. Be very clear. Start stop push buttons you do not connect to PLC. So now how many inputs are left? 5 inputs are left, 5 sensors, because push button we are not going to use. So 5 sensors you can connect to your PLC. But the question is, if we don't have start, stop, push buttons, how shall we start and stop our machine? Correct? If we don't have start, stop, push button, then how shall we start and stop our machine? Do one thing. Do one modification in your program. In your program, instead of x0, x1, use some flag. Why flag? Because flag has no physical existence. So it does not need any terminal. So flag you can use. So I have used here 2 flags. Any 2 flags you can use. But those 2 flags should not be used in your coil. Be very clear. You can use any flag. I can use M0, M1 also. But M0, M1 should not be used further in my program in coil. So I have taken here random 50 and 51. So 2 flags, simply you can say, I have taken 2 flags for start and stop. Now I shall go to HMI software, and as we designed visualization in the same way we work in HMI screen also, HMI software. So in HMI software, I shall create 2 switches, push buttons. And to those 2 push buttons, I shall give one M50, another M51. Now HMI is connected with PLC. We press M50 switch in HMI, in PLC M50 will get high. And as your circuit is for start, you can see first ladder I have given you here, this one. As M50 will be pressed, start signal will be high, it will make latch and your process will start. In HMI, as you press M51, this will break the latch and system will stop. So in this way, if you have limited number of input terminals on PLC and you have many manual switches, don't use manual switches. Only sensors you connect to PLC, because sensors we cannot operate from HMI. So all your manual switches like selector switch you can ignore, rotary you can ignore, push button you can ignore, and those instead of those manual switches you can create switches in HMI and you can give some flag. Is it clear, Devankar? Is it clear? Tell me, or should I repeat it once more? Tell me. Tell me. Did you understand? Okay. Not completely.
Sir, on small question.
Yeah.
Yes, sir. Everything is fine, sir. We are giving flag, and in HMI we are, connecting. But in HMI we will only draw the start and stop push button in HMI
Yes.
also
Yes.
during programming. I have seen someone doing. I don't know that.
Hmm.
So when we are doing that, why do we give why should we give flag? We can give X5 and X6,
See, that,
and we can.
yeah, that is the point. First, let me clear this, then I shall take another question from you. See,
Yes.
the question everyone try to understand. Sir has asked, can't we use X5, X6 because X5, X6 we have not used in our program. But you see, X6 and X5 and X6, these are hardware key. These are hardware key actually. Once more, I shall tell you. X5 and X6 will have physical existence, isn't it? You
Yes,
understand?
sir. But our HMI is also that sense. Touch sensor. It is also physical. When we stop, touch the start push button, I have seen machine running.
Yeah.
It is also like physical. But it is in touch mode, like phones what we are using.
See, I shall clarify your doubt. I will tell you, as per your question, I'm saying, you are asking why should we take M50, M51 there? Can't we take X5 and X6? We can take, but we should not take. Why? Because X5, X6, suppose in future we needed to connect some more sensors, then we shall purchase extension, and now extension address will be x5, x6, 7, 8, like that, 7.
Yes, sir.
So
Ah,
if you will use x5, x6 here, then
program will
those
confuse.
terminals will be used actually.
Yes, sir. Inside program will be confused. Okay.
Yes, yes. So you should not use physical address. These are physical address, right? No, X5, X6, these are physical terminal address. So you don't use that. Another thing, one more thing I would like to tell you people, that in some softwares, like I have seen some softwares, there we cannot operate physical terminals through HMI. So in some software, like in Delta only, today we shall use Delta HMI. I think for Delta PLC, try to understand. We have Delta HMI, okay, Delta HMI, and our PLC will be Mitsubishi. For Mitsubishi, they have allowed that you can use X0, X1 also to do start and stop from HMI. I can give
Okay.
X0, X1 as address. But if you will use Delta PLC and Delta HMI, for Delta PLC, they have not allowed to use X0, X1. If I give X0, X1, it won't be operated from HMI. I will have to give flag there. So it's not like if we have HMI, then we have not to use start, stop, push button. We have to use. In all industries, they use start, stop, push button. If they have HMI, then also they use start, stop, push button. So if you have start, stop, push button, then also you can give HMI two keys X0, X1. But I told you one condition, that if you have limitation, in that case you can use HMI. You can take advantage of HMI keys. Is it okay?
Yes, sir. Got it, sir. Thank you so much.
Okay, okay. So other people, you have some confusion that will be eliminated when we will do real time project. Okay, during real time project, it will be clear. Okay. Let me check if we have any question. Okay, he understood. Clear. Kindly repeat the last point, how to start the flag. That flags will be started from HMI, Tanesh. From HMI, we will operate the key and then flag will be operated. Okay, clear, clear. Very good. You all are very intelligent, I know. Next, what do we have? Let me see. Next, let me tell you about some brands also. You can see on your screen here. I have written make means manufacturer. Then hardware of HMI and software of HMI. I have told you, no, that we have software also for HMI. So if you have Mitsubishi, make HMI. If you have Mitsubishi HMI, Its hardware is called, actually hardware name you can say, hardware name is GOT. We call it GOT, Graphical Operator Terminal. We call it Graphical Operator Terminal. Then Allen Bradley has panel view. Siemens has OPTP. It has another name also, Siemens. Bezier is also, I have seen in pharmaceuticals, many Bezier HMIs they have used. So Bezier has E-terminal. Delta HMI is called DOP. Okay, these are hardwares. Now you see software for each. For Mitsubishi HMI GOT, you have to use software GT Designer. For Allen Bradley Panel View, for this software you will have to use Panel Builder. For Siemens, you can use either WinCC Flexible or TIA Portal. Bezier. Bezier has e-terminal. Its software is e-designer. Delta is DOP. Delta has DOP hardware and the software is DOP soft. DOP soft. So like that, it's not like we have only these HMIs. We have many HMI manufacturers. There are manufacturers of HMI who have no PLC, but they have been manufacturing uh, HMI. Okay. Now, question. I am asking you one question. Answer me. Can we interface Mitsubishi PLC with Allen Bradley HMI? Answer, please. Can we interface Mitsubishi PLC with Allen Bradley HMI?
I think it is not possible, sir.
Okay. Other guys? You can tell me, can we interface Mitsubishi PLC with Allen Bradley HMI? Okay, let me tell you. We can interface any PLC with any HMI. We can interface any brand of PLC with any brand of HMI, but there is one requirement. There is one requirement. The requirement is in HMI software. Listen, in HMI software, you must have that PLC option. Got this? When you open HMI software, then it will ask you which PLC you are going to interface, and it will give you default names. Some brand name will be given. So if your PLC name is in that list, you can interface that PLC with that HMI. If you don't have that name, then you can arrange that driver file. We call it driver file. Then you can arrange that PLC driver file from the manufacturer and can keep in your laptop computer. You can browse it. Okay, fine. So this must be clear. We can interface any brand of PLC with any brand of HMI. Is it clear? Or any doubt? Any doubt?
Yes, sir. Clear, sir.
Clear. Very good. Train has come, you see. Next.
Yes, sir. It's a railway station backside.
Okay.
Sorry.
So, no problem. It's very good actually. Now you
Okay.
see, now we shall proceed. This thing you understood, different brand. We can interface any PLC with any HMI. The requirement is that driver file should be in your HMI software. Now we shall implement this HMI on our existing project. Okay, now let me go to the project actually. Here, see this place. Look at this screen. I am not going to make it M50, M51. Okay, what we shall do, first we will do with X0, X1, and then to show you the use of M50, M51, I shall change it further. But first I shall do with X0, X1, because in industry you will have start, stop, push button, because they don't have issue of fund and all. In your college project, you will have issue of because you are going to invest there, you can ignore start stop and can start from HMI. So I shall use X0, X1. Let it be the same program. I hope you remember yesterday's program. The sequence you remember: first red lamp will be on, then yellow lamp will be on, then forward direction, then reverse direction. X2 should be always on, and green will be on with motor. Now, I am the client, you are the programmer. You have made this program. Or suppose you are new for this machine, you are new, and you have come for this project. The project is, I'm the client, I shall tell you my requirement. See, in my machine, I have five, one, two, three, four, five outputs. I want to display the status of all five outputs on HMI, first requirement. Second requirement, I want to operate my machine from HMI also. I have been operating from push button, but I want to operate my machine from HMI also. So in HMI, I want start, stop. Okay, someone can note down also the requirement. So first requirement was all five outputs should be displayed on HMI screen. Second requirement, start stop function we have to give to HMI. Third requirement, is sensor status, whether sensor is on or off, should be displayed on screen. Sensor status should be displayed on screen. Got it? Okay. Next requirement you see, all timers accumulator, all timers accumulator, I have to display on HMI. Note down. All timers accumulator we have to display on HMI. Next requirement you see, I have to display and I have to control preset value of all timers from HMI. Got this? I have to change preset value of all timers from HMI. Got this? Who has noted down? Tell me what are the requirements. Tell me the requirements, what I told.
All five outputs should be displayed on the HMI screen.
Hmm.
I want to operate my machine with HMI, means give the start stop function to HMI.
Hmm.
Third is sensor status should be displayed on the screen.
Hmm.
Fourth is all timers and accumulators have to be displayed on HMI.
Correct.
And fifth is we have to control the preset value of all timers on HMI.
Very good, very good. So see, how can we do all these things? We will do it practically. One modification is required. Be very clear. If you use HMI or SCADA, listen, if you use HMI or SCADA in your project and you have to change preset value from HMI SCADA, then one modification is required. Be very clear about this. Huh? You should have that in your notebook also so that you don't forget it. The requirement is we must modify our program if we have to change preset value from HMI or SCADA. And what is that modification? I'm going to show you here. You look at the screen, please. This is our first timer T0 K50. Obviously, whenever this enable is high, this timer will run for 5 seconds always, correct? In all cycles, it will run for 5 seconds only, correct? No? Now, I have to change preset value from HMI. So if we have K50 K50 is the fixed value, correct? K50 is the fixed value. If it is fixed value on this preset location, this is preset location, no, this is the preset value location. On this location, if we have fixed value, numerical value, we won't be able to change this from HMI. So if you have to change it from HMI, the requirement is you must have one variable address to this location, not fixed value. Be very clear. We should have variable address to this location where we have to change numerical value from HMI, applicable for timer, counter, temperature, pressure, for anything. If you have to change numerical value on any location, that location should be variable, not fixed. In codices, we had used variable address percentage MW1, correct? Percentage MW1 we used in codices. In Mitsubishi, it will be changed. In Mitsubishi, it will be changed, not the same address. In Mitsubishi, it is D. They have given D, variable address, data register. So what we have to do now, our modification will be and this D0 we shall give to HMI, and in HMI we give numerical value to D0, it will come to PLC. Is it clear? Is it
Sir,
clear?
please repeat once more.
Okay, once more, you see, if we have one timer, yesterday also we used, if we have a timer where we have T0 K50, this K50 is the fixed value. We cannot change this. This is numerical value already here. We cannot change this value. Always this timer will run for 5 seconds. But our requirement is from HMI, I have to change this value. If I have to change this value, it should not be fixed value. So you remove this fixed value. Remove it. Instead, you have to give some variable address where you can vary the value. Variable address where you can vary numerical value. For Mitsubishi, variable address is D. It is D. So now, instead of fixed value K50, instead of K50, you have to give D0, D1, D2, D3, whatever you want. We have lot many data registers. I think D700, I think it is up to that and more also. So we have a lot data registers. So this modification is required. This is must. If you do variable address here, it won't be changed from HMI or SCADA. For different brand, like for Allen Bradley, it is N7. For Siemens has similar address as we have in codices. Like there you have MW1 or VW1. We have many variables in Siemens. So in all brands, in different brands, you will have different variable address. For Mitsubishi, I told it will be D. For Mitsubishi, it will be D. So I have taken D0. So for each timer, we will have to change preset location. We will have to give D0, D1, D2, D3 like that. Is it clear?
Yes, sir.
Okay. Now I go to program and will make some modification. Look at the screen. How do we modify? This is the write mode, WRITE. Write mode is offline. So first we need to go to offline mode and then we can modify our program. So here you see, look at the screen. This T0 K50. What do we need to change here? It will be D0.
D0.
Yes, correct. Very good. Then here it would be D1.
D1.
Yes. D3. 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 Done. Okay. Tell me, you people, when we make new program or we modify, what is the next step after that? What should I do now after this?
Save.
Convert.
Save, huh?
Compile.
Compile.
Convert.
Convert.
Convert. Convert. Convert is the option in Mitsubishi. You see, yesterday we did it. So when this color is changed, you should first go to convert. Convert. It is done. Now I save it. Okay. Now let me get the PLC on so that I can send this program to PLC. Okay. Now you people have to answer. Yesterday we have done all these things. Tell me, for communication, what are the steps? You tell me the step, I shall follow here. I have to check communication. Tell me the steps to check communication, PLC, laptop communication.
Click online.
Online,
In that, click transfer setup, sir.
transfer setup.
Double click serial, sir.
Okay. Com port
You
number,
should
I have
check
3. I
that
have to check.
compound number 3 is not.
Yeah, it is 3 itself. So I make it 3. After that,
After that, click OK, sir.
okay.
It should be
Connection
saved.
test.
Auto connection check.
Yeah,
Connection check.
connection test we have to do. Okay. After that,
We should click OK.
okay, very good. Now you have to tell me the process of download. How can I send this program to PLC?
Online write to PLC.
Before that, you check the last letter.
The number of steps. Yes.
Yes, 35. So I go to online,
Write to PLC.
write to PLC. Then,
Main and PLC parameter may be on if you have to take the program as step range.
okay. So we have to select main and parameter. After that,
Click program,
Program.
yes, program and
range
Step
type,
Instead
range.
of hold.
Step
yes,
step
range.
range 0 to 35.
0 to 35.
correct. And execute. Done. It is done. Close. Okay, fine. So the program has already gone to PLC. Fine. Okay, it is ready. PLC is ready. Now, open your notebook and few things you note down. HMI has no relation with PLC logic. Logic, you understand, no the sequence. Means how does machine run, machine run? HMI has nothing to do with that. HMI has nothing to do whether it is traffic light program or any other machine program. It doesn't matter. HMI just requires list of data, correct? HMI requires list of data. So let us make a list of data. You people have to make the list of data. I shall tell you, and while design, I shall ask you. Note down. In our data list, what we have to configure in HMI is X0 start. X0 for start. Write down X0 start. Next, below that, X1 stop. X1 stop. X2 sensor. X2 sensor. X2 sensor. Then Y0 red. Y0 red. Y0 red. Y1 yellow. Y1 yellow. Y2 green. Y2 green. Y4 forward. Y4 forward. Y10 reverse. Y10 reverse. Y10 reverse. Okay, these are the inputs, outputs. Next, how many timers do we have? 1, 2, 3, 4 timers we have. Okay, can you tell me what is the address of first timer accumulator? Listen, what is the address of first timer accumulator?
D0
What is the address of
address.
first timer accumulator?
T0, sir.
D0
Then what is the address of first timer preset?
Sir,
K0.
sir, for accumulator it is T0, T0.
See, accumulator and done bit is its address. I had told you, no? So here, your timer,
T0, D0.
yeah, timer accumulator will be T0 and preset will be D0. Accumulator is T0, preset is D0. Okay. T0, correct. Very good. Okay, okay. Now note down, please. I shall tell you. Note down. Mute, please. T0, write down. Write down T0. Mute, please. Mute everyone. Mute, please. Write down T0. Any name we can write down. In short, let us write down TAC1, means timer accumulator 1. Or AC1 also you can write down. See, it is not syntax, just a name. So T0 accumulator 1, in any name you can write down, no problem. T0 accumulator 1. T1 accumulator 2. T1 accumulator 2. T2 T2 accumulator 3. T2 accumulator 3. T3 T3 accumulator 4. T3 accumulator 4. T3 accumulator 4. Okay. Next. D0 preset value 1. PV1 also you can write down. PV1. D0 preset value 1. D1 preset 2. D1 preset value 2. D1 preset value 2. D2 preset value 3, D2 preset value 3, D3 preset value 4, D3 preset value 4. See, while working on HMI, the steps we follow in industry, the same we have been following here. So we must have a list of data, then we should go for HMI screen development. Fine. Now, it is done. Once you bring me on main screen so that I can show you HMI. Okay. So this is one HMI. This is Delta HMI. It is correct. It is Delta Mech HMI, Delta manufacturer. It is touch panel, completely touch panel. Behind this HMI, tell me how many communication ports do you see?
4.
Three. Three.
See, mainly three, but we have five here, but main are three. Fine, fine, very good. Everyone is correct. They are texting here. Nice. Now you see, listen. This is for power supply. I know it is not very much clear, but just for idea. We have positive, negative, and here it is written also 24 volt DC. This, where it is here. Can you see this one? This is given to send or receive data to HMI. Means program, you can say HMI program. And there is one USB port also. So you can use USB also to communicate it. Okay, let it be. We are going to use here, they have given here, COM port 1, 2, 3. COM port 1, 2, 3, they have given here. You can see now. 1, 2, 3. We are going to use here COM port number 1. We are going to use here COM port number 1. Okay. So this connection we will do further. Power on. I have to just connect 24 volt DC and it will be powered on. Before you start HMI screen development, you should check that HMI hardware name, HMI model name, because Delta has many HMI hardwares. So you must note down. You note down, write down. I think now I shall share and will write down myself here. But you can try to write DOP, 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 B0, B0, 7, B07, S415. I shall write here. It is DOP B07 S415. S415. You work with any brand of HMI, no problem. You work with any brand of HMI, but you have to follow all these steps what we are going to follow now. So very first you should note down the HMI hardware name. You keep this in your notebook. I shall ask further. Okay, now I go for HMI software. I'm going to start HMI software. Look at this screen. Where it is, here I have kept on desktop. And if you want to search here, you will have to search DOP. should come, but it is not coming. Definitely it comes. Okay, let it be. It will take time, I think. So better I open from here shortcut. I've kept here. But it will come there. If you will search DOP, it will come. Yes.
So is this a open source or a paid software?
Yeah, Delta, all softwares are open source. Delta HMI software, PLC software, Delta has SCADA also. All are open source. From its site, you can download. Delta website, you can download. Okay, so you see, this is my previous training program screen. The same program I had done almost. So we shall try to design the same. We have to start from scratch. So as we open software, first we should take new file, correct? We should take a new file. See, all these steps will be applicable for any brand of HMI. So as you take new file, two things it will ask you. Listen carefully. As you open any HMI software, two things it will ask you. First is HMI hardware, or you can say HMI model name you have to select. Which HMI model you're going to use, that you have to select. Ours is B07S415. B07S415. It is here. B07S415. Correct. So I have selected HMI hardware. After that, you have to select communication port number and PLC. Try to understand. You need to mention which PLC you are going to interface. Okay. You need to mention which PLC you are going to interface with this HMI and through which COM port, through which communication port. Okay. So you have to mention your PLC hardware and the communication port of your HMI through which you are going to connect your PLC. Here by default it is COM port number 2 selected, but I have to connect with 1. So I remove COM port number 2 and I shall go to COM port number 1 will connect to this. Okay. So I have gone to COM port number 1, clicked connection. Now here you can see, look at the screen. They have given all these brands, your Mitsubishi, Allen Bradley, Siemens, all are given here. Delta is also there, but we have to connect Mitsubishi. Here it is, you see. Explore Mitsubishi. You can see FX series, FX2N CPU, FX3U, modular PLC, all options have been given. Ours is FX2N, so I select it. Is it clear up to this? Tell me.
Yes, sir.
Okay, clear. There was one. How motor rotates forward and reverse. Ravi Teja, we will see while we make program, we will see forward reverse. Understood. Okay. Next, you see, you have to do finish. So these two things you have to do. Select your HMI hardware, then select your PLC and COM port number of HMI. Done. Screen is open. Here only we have to design the things. It is same as visualization. What you did in visualization, you have to do the same thing here. Method can be different, but same thing. See, that's why I use visualization from first day. Once you do visualization, your HMI and SCADA will be so easy to understand. So now you see, in HMI, in visualization, what you did, you took one rectangle, double clicked, two colors, correct? Initial color, alarm color. Then address, correct?
Yes,
Two
yes.
colors, yes, yes. So the same thing we have to do here also. How you see? Note down. If you people want to note down, you please note down. I'm showing you input. Okay. First you note down for input or switch. For input or switch, here the option has been given button, button, button. In different brand of HMI software, name can be different. Be very clear about that. But process will be the same. So here it is button. I click it. As I click button, they have given different type of buttons. They have given many types. So ours is momentary. Momentary is tap actually, push button. Momentary is tap. Momentary is tap. Momentary is tap. So we have to select here momentary. As I have selected momentary, I draw a switch like this. Double click. After double click, as I told, we have both options. Oh, we have that option, change color. So you see this one, please look at the screen. See this, state, STATE. It is written here, state. State 0, state 1. State 0, what color you want. State 1 means alarm color. State 1, what color you want, correct? So you can give, like suppose initially you want this color only. So state 0, you leave this. State 1, you want green color. So you can take green color from here, like this. Okay, so it will become green. There is one interesting feature. I shall not take color. You can take color, no problem. It's okay, it is done. After that, you have to go to main, and in main, you have to give address here. That is it, nothing else. But I want one thing here. I go to zero state, and I shall take ready-made picture from its library. So you see this. Keep patience. We will give enough time to learn HMI, but it would be very much perfect for you. So look at the screen. I have selected zero state, means when switch is off, how will it look? I go to picture. Here I select 3D button. 3D button option is given here. 3D button. You see, they have given you ready-made picture of switch. I want green switch for start. So when switch is not pressed, zero state, when switch is not pressed, it will look like this. So I select it. After selecting this, let us fit this in this rectangle. So I go and will do stretch all. As I do stretch all, it comes inside. Done. Now I go to one state. In one state, again, I go to 3D button. And you see this, when you press push button, it looks like this somewhat. So I click this one, stretch all. So your zero state, one state, correct? It is done. Selection of design is done. Now another thing is address we need to give. For address, you click main, and in main you have to you have to select this, and there, what is the input address? Tell me, what is the address for start? Start address.
X00.
X0.
X0. So I select this X from here. Can you see? And 0 I can select and make it enter. So you can see it is X0. Very good. Very good. You are answering in group also. Correct. Correct. You are correct. It is X0. Okay. Is it clear? Is it clear? Tell me.
Yes, sir. We'll move further, sir. If any doubt, we'll ask you.
Okay. 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 I can move. Yes. 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 Okay. So one more switch. I think I can copy paste, but I won't copy paste, but we'll do the same thing so that it can be very much clear for all. So I shall design one more switch here, and we'll double click, we'll go to zero state, picture, 3D button, then off button, all. One state, picture, 3D button. Oh, I'm sorry. I have to take a red this time, correct? I have to take red. So red button, let me take. Okay. Stretch all. It's zero state also. Let me bring red here. I can take a red button here. Okay. Go to main, and in main you have to give X1. X1. Enter. Okay. So two switches we have designed. So either you take color or you take picture, no problem. Then you write down for output. For output, the option is indicator. For output, the option is indicator. 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 In indicator, you have to take multi-state indicator. In indicator, we have to take multi-state indicator. Multi-state indicator. Multi-state indicator. I draw it. Double click. Here also we have the same option. Either you take two colors or you take picture. I go to picture. Go to picture, and there you select 3D lamp 2 state. 3D lamp 2 state, on off state. So first it is red lamp, off lamp. Then you go to lamp 2 state, take on lamp, stretch all. Then you go to main and give the address. The output address is Y. Y0 you have to give. Enter. Done. So you have taken here one output. In the same way, you have to take three outputs. So I shall do copy paste this time. So I shall do Control C, Control V, and we'll make it fast because time has been running fast. So Y0, Y1, and I go to picture and we'll change the picture. Yellow. So yellow, one state, yellow. Done. So it is Y1. Enter. Now copy paste. Red, yellow, green. For green, it is Y2. And you go to picture, you make it green, off lamp. Go to one state, make it green, on lamp. Done. So three outputs we have taken. See, for forward reverse, we cannot see, we cannot show the things like it is running in forward and it will run in reverse. Though we have option that we can show the running things, but for that I will have to modify program. So simple method I tell you, you can just take one multi-state indicator in the same way, and one you can take for forward and one for reverse. So for this, you have option of picture. You can take fan also. There is a fan here. So you have design of fan, different kind of fan. You can take any fan here, or simple lamp also you can take, and you can give the name forward reverse. Now I go to one state,
And I take another picture. We have option, we can show this running also, but for that I will have to modify program and will have to write some logic. So better you see the simple thing, don't complicate it. One thing I can do here, when I go to one state, I let me give address. Address is Y4. And here you see blink. In one state you have given address and here is blink. Make it yes. So what will happen actually, when Y4 will be on, it will just show you the thing blinking. You can understand, okay, it is on. Okay, done. Now I go for CV and here I shall just change the address, nothing else. Y10. Done. Enter. After this we want accumulator and preset value. For accumulator you write down. For accumulator, see, this accumulator will be applicable for timer, counter, temperature, pressure, flow, displacement, level, for anything. So whenever you have to show, you have to display numerical value, accumulator you have to take. For accumulator, the option has been given display. Accumulator option has been given display. Accumulator option has been given display. So I take a display here. In display, numeric display. Display, numeric display. Display, numeric display. Display, numeric display. So one display I take for this. Double click. And there is no 0, 1 state. It is just one screen. Here I give address. Tell me, what is the address of accumulator? First timer accumulator. What is
T0.
the address?
T0.
T0, yes. T0. T0, enter. So I have taken this. And you know, just give this, make it okay, it is ready. But few things, let me show you. You just give T0, it will display the things. But in Mitsubishi, for 5 seconds, it will show you 50. For 5 seconds, it will show you 50. So you should scale it so that it can show you 5 only. For 5 seconds, it can show you 5 only. For that, you go to gain, note down GAIN, gain. In gain, you can make it 0.1. 0.1. In gain, you make 0.1. How will it do? How will it work? Further, I shall explain. First, you just note down that in scale, you make it 0.1. It will display 5 only, not 50. And then I want to increase the font size so that we can see this clearly on screen. Okay, other things, fine. Fine. So now it will be looking big. Now I want the same, Control C, Control V. This is for yellow lamp. Yellow lamp will have T1, T1, and the same, that scaling will be there. Again, Control C, V. This is for forward. For forward, it will be T2. For reverse, it will be T3. So here I make T3. Done. It is done. Now we want preset value. Now we want preset value. For preset value, write down, the option is input. For preset value in this software, they have given option input. For preset value, it is input. As I click input, numeric entry, numeric entry, numeric entry.
Now, I have to change the value for this. I take here. Double click. Same thing. Give address and scaling, nothing else. Give address and scaling. Okay. So what is the address for preset value? Tell me.
D0.
D0, correct. D0. Very good. And here scaling is required. So 0.1 gain I have to give. In text, let me increase the size so that we can see this clearly. Okay. Okay, this I will have to make 2, 1. Fine. Done. So from here, we shall change the value, and here we will monitor the value. Control CV. Here I take, and it is D1, D1 I have to make here. Nothing else. Everything will be the same. Control CV. Here I take this. So it would be D2. Enter. And Control CV. It would be D3. D3. Okay. All done. Now I go for sensor, correct? What sensor is left? For sensor, tell me. For sensor, you can take output itself. For sensor, you can take output only. So you click this multi-state indicator, and if you want here, you can take like this. See this, how to do. It is output only. But I am not going to take picture, but I shall take two colors. Zero state, when sensor is off, it will be red. When sensor is on, it will show you the things green. And now you go to text actually. In text, you have zero state, one state. So zero state. Zero state means when it is off. So I type here simply sensor off. So it will display sensor off. I can increase the size. Sensor off. Will make it bold. Done. So sensor off. Now I go to state 1, which is here also. It is given here also. Sensor on. So sensor on, it will display when it is state 1, when sensor is on. Will increase the size and will make it bold. Now I go to main, and there I shall give address X2. Enter. Done. So everything we have made. Let me save this.
Sir,
Yes.
how can we bring any logo we want, or company name, or our name, something, what our identification like that? How can we bring?
So picture, some picture you want to bring there, right? Logo.
Yes, sir. But till now in picture we were taking only which was been in the library of this HMI.
Ready-made. We may take. See, some logo if you want to take, we will have some option to browse. We will have to search. Okay, I
Sure.
shall search that and will show you. But we have
Okay,
all
sir.
options here. Many options.
Okay, sir.
Everything you think you can do here. Okay. So that can be done. First, let us see this. After that, we will make some experiments. So we have saved
Okay,
it.
sir.
Now we go for one more thing. Let me show you here. We can create multiple screens, because when you have a good machine, you won't have only 10 or 15 addresses. You might have 1000 addresses, 1500 or 2000 addresses. So on one screen, you cannot accommodate all. So you will have to create multiple screens. How to create multiple screen? You see, look at the screen. For that, you have to go to screen. Here it is given screen. Take new screen. Take new screen. You can give the screen name like suppose I want this screen to display timers only. Timers. and I make it okay. So you see one more screen. Look at this. Look at this, please. Look at this screen here. Left previous window, next window. So I click this. Previous I click. So I came to this. If I click this, I will go to next. Next. So if you have 10 windows, while design, you can use these two and can go to your screen for modification. So I go to this and suppose I copy these two only, just to show you, nothing very serious, just to show you. And here I paste. So now we have two screens. The question is, when you download this main screen, this screen will come on the HMI. If you have to go to another screen, how will you go? So for that, you need one key to go to another screen. So for that, you need button. In button, we will have to search. Go to screen. Here you see. In button, we have option go to screen. So I take this and I draw it here, suppose. And this key, double click. This is for timer, right? This
Next
is for
page.
timer. Yeah, next or timer. This is for timer. So I just write the name and let it be color is not required. Just to show you, go to main and go to screen. Where have you to go? You have to go to screen number timer. Here you see. All your new screens will be visible here. Where you want to go from that switch, you can select from here. So I want to go to timer 2. Okay. Okay, done. Nothing else. So you take a switch, go to screen switch, give name and tag where you want to go. Now you go to main screen, timer screen, and copy this. Control C. Go to timer screen and copy paste here. Now I shall just select. I have to go to main screen and will change the name. This is for main screen. So we can switch using these switches. We can switch the screens using these switches. Okay, finally. Let me, and then we'll send program to, let me do this. Keep patience. Here, green wire is for positive and black is for negative. So green I need to connect to positive of SLPS. Let me connect. And black. Black I need to connect to negative. Okay. So our HMI is powered on. First, let me show you how we download, and then I shall show you the execution. So now actually I'm going to connect. I hope in small screen you can see me. Am I visible on small screen?
Yes, sir.
Yes, sir.
So there is one cable here. This cable is actually, you know about this cable. This cable we use to printers. Behind printer we use this cable. So the same printer cable is for this HMI. You have to check which cable is required for your HMI. So this I connect to our laptop. So this I shall connect to laptop here. Okay. Once let me check where has it been connected. been connected. So device manager. So I have opened a device manager to check to which COM port this HMI has been connected. Wait, please. Here you see port HMI COM port number 5. It is shown here HMI COM port number 5. Okay, that is it. Now I go to option tools. In tools you have option, you can see tools, you have option download all data. Download all data. So on small screen you can see I have previous program. If you have to uh, take this, if you have to save this, then you receive all data, means upload all data and save that, then you download new one. Because when you send new data, previous will be erased. Previous will be erased. So I have not to save that. So I just click download all data. Download all data. I click it.
Hello, sir.
Yes.
To connect this HMI, we will need some different drivers to install it, no?
When you install, its software driver will be installed with that.
Okay, sir.
You can see on your screen, it has been sent actually already. The data has gone to HMI already. Now I stop sharing and will show you the things here. Okay. But it's too bright. Are you able to see the devices here? Button
But
and
it is blur, sir.
blur because of
But one thing we can do
no,
is, no, sir, we'll take that video and we can, you can show us.
I, I need to show you in video. I wanted to do this live, but I
No, take it a
just
bit back. More close to your face. Yeah, now we can see a bit better.
I think we need to tilt it.
Sir, tilt it to slightly tilt. Yes, sir. Now
But
visible.
still you will not be able to see the uh, data entry. You won't be able to see the data entry. Okay, what I shall do for now, I shall operate the things and will show you in blur condition only. In second session, during lunch time, I shall make one video of execution and will share. Okay, so for now simply let me show you the
Yes, sir,
execution.
that is only the one option left.
Yeah, because it's too bright. Let me switch off light and we'll check, but I don't think it will work. So it did not work. Light off did not work.
Yes, sir.
Okay, okay, I shall do that only. For now, let me show you the connection here. After that, you see you have PLC. Yesterday we made program. Keep patience, please. Nothing is visible. Okay.
But at least you can see these outputs to get on off.
Wait, please.
So that thing you understood, that connect that communication cable, connect it to your PLC, laptop, and send data. You have sent it already. After sending that, after sending that, you don't need this programming cable. So you can remove it if you want. So I have removed it. I removed. Now I have one HMI with some program. Actually, it is designed with some program, let us call it. Now you have to take the normal communication cable you use for your PLC. So yesterday we used this cable, right? Red cable, 9 pin. And here on COM port number 1 also we have 9 pin. I can connect it. And let me tell you, now we have only two things. Now we have only we have two connections. PLC is connected to HMI, nothing else. PLC is connected to HMI through PLC communication cable, through PLC communication, nothing else. Okay, so very first I need to enter values. So for that, what I am doing, I just click preset value number 1. As I click, one number pad has come, numpad has come. On that numpad, I can enter, okay, first it should be 5 seconds. Second timer, it should be now 4 seconds I'm making, 4 seconds. Third timer, I want to make 6 seconds and next 7 seconds. Enter. So by touch only, as you touch that preset value in HMI, numpad will come and you can enter your number, what you want. After that, you see, first I shall operate it from push button, and then I shall operate it from, there is no option, you see. No, nothing. You cannot see. Okay, let it be. So first I operate machine from push button, start push button, I press here, and it is not on because on HMI screen actually it is showing sensor off. That I will show you video by sure, don't worry. So it is showing sensor off on HMI screen. So directly we can understand, okay, sensor issue is there. So now I shall fix sensor on HMI. Now I have green color sensor on. Now I press start button and you can see this red lamp is on here, and in HMI also red lamp is on. Now yellow in HMI also yellow is on. Now motor is running in forward, so that is shown in HMI also. And it is repeating the process. I stop it. Now you people see, I shall not press push button here, but I shall press start button in HMI. You see here, I press this and you see this red lamp is on, and now yellow, you see yellow is on. So you can see I have started this machine from HMI. I stop it from HMI, you see. Stop. So from HMI I can do start, stop, start, stop. Red lamp you can see start, stop, start, stop, like that. Okay, this is it, nothing else. I can show you all the function in video, but ask me if you have any question regarding HMI. Ask me.
Hello, sir.
Yeah. Tell me.
Yes, sir. I was talking about that logos and our brand name and all.
That let me search in software, because I told you many features are there. In fact, not only that,
but we have security level for each data. Security level, what is this? Security level means if anyone has to access this HMI can enter password. We
Yes,
can
sir.
give we can give password level also, like start stop I will keep in one level, timer preset value change I shall keep in some level. So we will give operator level one password, higher
Yes, sir.
level one password. We have that option also in HMI. Very easily we can do another feature, let me tell, but I won't be able to show in this training program. So another feature of HMI is recipe. Recipe, I hope some people have heard about this. Recipe handling.
Okay.
Recipe handling, what is this? In industry, it is used. With
Mhm.
one example, let me tell you what is
Sir,
this.
one small thing.
Hmm.
Whenever the program which you are given and whenever your PLC going to the company will go in your company name, sir, interval like that. That one I'm asking.
I didn't get once more, please.
No, sir. For example, the programmers programming, interval is programming, and they are giving to one company.
Hmm.
So, in when the HMI owns, there will be the company name as a interval, like your company or
No,
Tata
you
or.
see, no, you see, if this HMI
Mhm.
is in Tata Motors,
Okay.
so as you power it on, Tata Motor logo will come. Programmer logo won't come.
Yes, sir. I know that, sir. For example, I told how to do
If you
that.
want, you can do that. If you want,
Yeah.
you can do that, but you take permission from them.
Now you can show us, no, sir. Okay, sir. Thank you.
Okay, no, you got
Yeah,
this.
sure. Okay, okay, okay. Thank you, God, sir.
Okay. But you want me to show that, right? How to
Yes.
give logo and all. Okay,
Yeah.
that I will do in lunchtime. I will do and will show you.
Thank you so much, sir.
Okay, fine.
Thank
Okay. Other question?
Hello, sir.
Hmm.
When we connected the HMI, we used the same serial cable to PLC.
Hmm.
But what if at the same time we want to make some changes in the PLC code? We will have to remove the HMI connection, or
See, if on your PLC you have two communication ports, then you can use one for HMI, one for programming part. But if you don't have, you can remove it. But in HMI, I had worked with Mitsubishi HMI, GOT. In that HMI, you have option, ladders can come to your HMI and there also you can modify. Or another thing, let me tell you. Now, if you want to take program of PLC to your laptop, on on screen, let it be, I will have to share. You can do one thing. Your PLC is connected to HMI. HMI is connected to laptop, correct? We can do that, no? We can connect PLC to HMI. Already I have connected. Then I have to connect programming cable of HMI to laptop. So HMI and laptop will be connected. So between laptop and PLC. See, between laptop and PLC, you have HMI, and through HMI, you can communicate your PLC. And you can receive and send program through that. I had used e-terminal. Uh, what is that? Mm, e-terminal of Bejer. In that also I had done. So that HMI was in between PLC and laptop, and we could send receive program through that. In Siemens also I had done. We can send receive. In this I have not tried. I will try. But I want to say that we have option that we can send receive program of PLC and HMI both by HMI communication cable. Okay, all three should be interconnected. We can do that.
got it, sir. Thank you.
Any other question? I was telling you about recipe. Recipe is like, I told you, if we have several products like product one, product two, product three. For product one, suppose we have here four timers. For product one, each timer should be 5 second, 5 second, 5 second, 5 second. For product two, it should be 10 second, 10 second, 10 second, 10 second, or it can vary also, no problem. So for three products you have, suppose. So for product one, you can make one recipe. In that recipe, you will have product one recipe, product two recipe, product three recipe. And for product one, you will be able to keep your data saved. That for D0, this is the value D1, D2, D3, we have this value. For recipe 2, you can store another value. For recipe 3, you can store another value. Okay, actually, I should not say recipe 1, recipe 2, recipe 3, but in one recipe, product 1, product 2, product 3. So each product data, you keep it stored. And when you are going for product one, you just go to recipe, click product one, respective data will move to respective data register. So you don't need to enter, if you have 100 data registers, you don't need to enter all 100 registers, but it is already set. You just click once, product one, all saved data will move to the respective data register. This is recipe handling. Got it. Okay. Anything else?
Sir,
Yes, sir.
sir, I think you was talking about you was telling about the passwords. One doubt in that,
Yeah.
sir. My need is I need to set three passwords. One password for login that everyone can do for data
Hmm.
monitoring, data reading, everything operators for them. Next,
Hmm.
for engineers, one password to look any kind of this temperature, pressure, flow, and like that
Hmm.
means. And third password for the administration people. This thing
Hmm.
can I know. I mean, I can get that information, sir.
Yes, we
By
can do that. We
Mhm.
can do that. I told you we can have different level, password level. Okay.
Yeah, yeah,
As you,
yeah. That.
so different password level you have made, and
Mhm.
you have selected. Okay, like start, stop will be in this level. Then
Mhm.
timer will be in this level. Temperature will be in this level, and administrator.
Mhm.
Upper level can access lower level, but lower level cannot access upper level.
Yes, sir. These things can we see by your practical
Uh,
method.
in this practical, I won't be able to show this
Sorry,
because
sir.
it will
Thank you
take
for.
time. Huh? Huh?
But
It will
you can
take
give
time.
us
You
some
understand?
steps, just point number or like a flow drawing we can write up in our notes, which can be it be easy for us in future.
Okay, means how do we do that, right?
Yeah, yeah, yeah. Start and
So,
stop and this step one, step two, step
means
three.
how do we set level password level that you want to
Yeah,
know,
yeah,
right?
yeah, yeah. That's it.
Okay,
That's it.
so in the evening I shall try to, if I get time, I shall try to do that.
Thank you,
Okay,
sir. Thank you so
fine,
much.
fine,
Sorry for
fine.
giving you an extra
No
load.
problem, but you see, it happens when when we talk about HMI. You be very clear in 2 hours. What can we learn? You can
Yes,
understand,
that's
and
true.
in 5 days, what we can learn about automation. But I have
Yes,
been
sir.
trying level
Yes,
best that at least you understand the basic and you can start working on it.
yes, sir.
Okay,
Yes, sir. Yes, sir.
fine.
Thank you, sir. Thank you so much.
Okay, if you have any question, you ask, or we shall bind up. I think there is no question. Okay, admins, we shall bind up. Okay, thank you. Bye. Meet at 1 o'clock only. Yeah, bye.